Our second of three chord theorems we're going to take a look at has to do with diameters. And specifically, what I know is that if I have one chord, for example SQ, that is both perpendicular, and I can see it's perpendicular by the right angle symbol, and a bisector, meaning it cuts another chord equally in half, then that first chord, SQ in this case, is going to be a diameter. And so what I'll do is I'll kind of add that center of the circle, and it'll be kind of my giveaway that this is in fact a diameter. So once again, and by the way, vice versa of this is also true, what I try to do in these problems is try to make my examples look like these diagrams, and that's kind of how I answer the question. So the circle to the right of this kind of gives me the vice versa of that. This time, because they gave me the center, I know that for sure EG is a diameter. So that tells me two things. It tells me, one, it's going to be perpendicular to a chord, which I've got right there, and if it is perpendicular, it's also going to be a bisector. So I can add tick marks right there. So let's go ahead and take a look at these first examples down here. They asked me to identify whether QS is a diameter of the circle or not. I'm not allowed to assume it. I've got to base it on those two facts up above. It's got to bisect something and be perpendicular. So I can see that in this first example, both of those statements are true. It's perpendicular to a chord, and it also bisects that chord because those two pieces are congruent to each other. So I know for sure that yes, segment QS is a diameter. I can add in the center circle, or the center point that kind of gives it away. My explanation would be two things. One, it's perpendicular to the chord, and two, it bisects the chord. I need both of those things to be true. Okay? In the next example over here, I can see again that I do have a perpendicular segment. However, this chord is not bisected. One piece is 19 and one piece is 20, so it's not cut evenly in half, which means no, QS is not going to be a bisector. Or I'm sorry, QS is not going to be a diameter, and it doesn't bisect it. And here's a couple of problems using algebra and the theorem we just talked about. In the first circle, I see that this is in fact a diameter because it goes right through the center of the circle. So that tells me two things. If it's perpendicular, then this chord has to be bisected. Those two pieces have to be congruent. Once again, I'm just kind of using that example we looked at to add tick marks as I can to these diagrams. Because those two pieces are equal to each other, it tells me what equation I can write. I know that 4x has to equal 3x plus 7. If I subtract 3x from both sides, this equation kind of solves itself then. I just get x equals 7. In my next example, I'm going to do something very, very similar. In fact, well, the same exact thing. I have the diameter. I know that for sure because it is going through the center. I can see that was given to me. Because it's perpendicular to the chord has to be bisected. So those two pieces must be congruent to each other, which then dictates the equation I've got to write. I've got to set those two pieces equal to each other. 5x minus 6 has to equal 2x plus 9. So let's solve that and find x. I'm going to subtract 2x from both sides, which would leave 3x over here. At the same time, I'll add 6 to both sides, which gives me 15 on the other side. Dividing by 3 gets me a final answer of 5.